Good evening, everyone. I am K.S. Narayan on behalf of IIT Alumni Center, Bangalore, welcoming you for the 50th webinar of IITACB. We have been conducting these webinars online since April 2020. My colleague Ashok Kamath used to be the host along with Sushila Venkatraman. This has been a very successful series, and in case you have missed it, you can find our previous webinars on our YouTube channel. So on this occasion of this Golden Jubilee, we have the opportunity to hear Dr. Kumar Sivarajan, CTO Tejas Networks, on the real status of 5G. You know, the Wikipedia definition of 5G is it is a 5th generation technology standard for broadband cellular networks, which cellular phone companies began deploying since 2019. And it is a planned successor to the 4G networks, which provide connectivity. Kumar is the right person to convey us on what it really means and where it is going. Kumar, a brief background on Kumar. He holds a BTech in electrical engineering and alumni of IIT Madras, and then went on to do his MS and PhD from Caltech. He has been in the field of telecommunication for the last 3 decades, and he made a wonderful example of a transition from academia to industry. He's a fellow of Indian National Academy of Engineering, recipient of the DST Swarna Jayanti Fellowship. He's also a recipient of the IEEE Baker Prize Award. Kumar was the first chairperson of the Governing Council of Telecommunication Standard Development Society of India, TSDSI, which is an organizational partner of 3GPP, the global standards body responsible for formulating 5G standards. He's also authored best-selling books and written several papers. And along with him, we have moderating this seminar is Pamela Kumar, who is the current Director General of TSDSI. She's also the President and Founder Chair of Cloud Computing Innovation Council of India. She's an alumnus of Punjab Engineering College, Chandigarh, Raj's University, and IIM Bangalore. Pamela brings with her a rich experience of, again, 3 decades in communications, computers, and semiconductor industry. She is also quite accomplished, holds many patents, been an invited speaker for many global forums. She is on the governing board of Indian Financial Technology and Allied Services, IFTAS, and the PEC University of Technology. She is the Bharti Chair for IT Research and Member Research Council, UIET Punjab University. She also mentors startup in this space, communication space. So I look forward to this wonderful talk and discussion, and I encourage the audience to engage in this discussion via the Q&A box, not the chat box. And in the end, we have my colleague, Dr. Sushila Venkatraman of IITACB, who will be closing the event. Over to you, Kumar.
Thank you, Narayan, for the introduction. Let me begin. Okay, is my screen properly visible?
Yes.
Okay, great. Thank you. I thank you, Professor Narayan, Sushila, and the IIT Alumni Association of Bangalore. It's a great opportunity to be here and talk to you about 5G. I noticed that you had talks about 5G in this forum in 2020 and again in 2021. So I think it's timely we take stock in 2022 on where we are. Okay. So we have high expectations from 5G, all of us. You know, we expect India is embarking on a digital transformation. I'll be very India-centric in this talk, and we expect many of these things to happen from 5G. So there is a lot of focus today on delivery of food and shopping and everything else. I think we can get something in 10 minutes now through Blinkit and many other places. We want it even faster with drones perhaps, and we expect 5G to deliver fast logistics. During these COVID times, there's a lot of focus on remote learning. Many of our children have been forced to learn from homes, and we've been disappointed at the effectiveness of this learning. And we want 5G to solve the problem using virtual reality or whatever. We've been working from home. Factories have to run. We've had trouble getting people to factories. So we really think in the next Industry 4.0, factories should be run remotely or autonomously with robots, and we expect 5G to do that. Often, Wi-Fi in the office doesn't work quite well. You end up switching on 4G, especially if you're moving about. We want private networks based on 5G to solve this seamless mobility in campus networks. We all get stuck in traffic in Bangalore. We have automatic cars, but not good enough. We really like autonomous cars or remotely driven cars. Can't get a driver. And again, we expect 5G to solve the problem. And maybe we can even do remote farming with 5G. So we have high expectations from 5G. But let's look at where we are in the pre-5G era today, which is prevalent in India anyway. So we all need to connect to the internet. You are connected to the internet now. So there's an optical network at the back which no one notices, but this is bread and butter for my company. So we transport all the traffic to the internet. If you're at home on a Saturday evening, as most of you are, we're seeing this on a fiber optic connection. If you're home, which comes through FTTH or GPON, it then connects in turn to this backhaul network. On Monday morning, if you're in the office, you will be connected to some kind of packet network, Ethernet, IP router network in the office. In between, you're connected on your mobile phone on 4G today and hopefully 5G tomorrow. Occasionally, and very often in airports, we are connected on Wi-Fi, okay? And in some sense, and Wi-Fi is unlicensed, it's a bit of a nuisance to get into that Wi-Fi network. You need passwords, OTP, and so on. In a way, the first application of 5G is to give you, is to replace these Wi-Fi access points with small cells, high capacity based on 5G. And for those of us who don't have fiber to the home, 5G can provide a very reliable, high capacity broadband connection to the home. So really the first application of 5G, which is different from 4G, is what is called fixed wireless access. We didn't hear the term in 4G, and it sounds a little bit of an oxymoron, but really it is necessitated by the inability to get fiber to all buildings, especially many homes. Many of us have it, but if you look at the rest of India, most homes don't have fiber reaching their home. So the first new use case of 5G, which is coming up, is fixed wireless access to provide good broadband to homes, primarily to homes. And we can see that there are several operators who made fixed wireless launches in 5G. In fact, a few years ago, several people, we were starting to fix wireless in 4G as just for some niche applications, and people said fixed wireless is never going to take off. But lo and behold, in 5G, there's a lot of fixed wireless. So the promise of fixed wireless is that you will get broadband, fiber-like broadband, but over the mobile network. And it promises to be much cheaper than taking fiber to the home, especially even in developed countries. In developed countries, the cost of getting the fiber through your front yard is quite high. Whereas if you had 5G, giving you a gigabit per second to your home wirelessly, that's a very good use case. But we want 5G, and everyone wants 5G to go beyond internet connectivity. So internet connectivity will be one slice. So in 5G, you have this notion of slice, which is an end-to-end, if you want a virtual connection through the network. So 5G will first give you the basic internet slice. On top of that, many of us will have broadband applications or enhanced mobile broadband applications. This is supposed to be a high-speed train. So maybe you have to do a video conference from a train and you want a reliable connectivity, and 5G is capable of providing that. In fact, 5G even supports 500 km/h speeds just to take care of bullet trains. So beyond basic internet and enhanced broadband, 5G can do other things. with things, so 5G is grounds up designed to address many, many more users than there are people in the world, on the planet. So 5G is necessarily targeting the Internet of Things, the IoT space. So the idea is cars, some wearable device that you have, your Fitbit or equivalent, all of them will have a direct 5G connection, not a Bluetooth connection to your phone, but a direct 5G connection that will be monitored by some kind of over-the-top service provider. So Internet of Things is expected to be very big in 5G. I mean, this of course includes things like light meters, water meters, pollution sensors, and so on, but also wearables, appliances at home, maintenance of car parts, batteries, the car itself. So all of this is expected to happen. And the third facet of 5G is low latency applications. So here I've shown machines being operated, drones flying. There's also a recent application of controlling your laptop or computer with something embedded in your brain. That's what that last thing shows. So this is also the promise of 5G, the lower latency and go well beyond internet connectivity. So let's dwell on some applications. Okay, what is been the target for 5G. So here's how autonomous driving is expected to work in 5G. Okay, so you want to go from Bombay to Delhi, you're driving your own car, but you're not driving, you're in your own car, but it is self-driven, and it's of course an electric vehicle. This is 2025, let us say. So along the road, you have a 5G network. Okay, and so your car is guided by the 5G network, and it drives safely without bumping into someone in front. When you change states, you may change mobile service providers. So you will have to go to the new provider. You will have to pay tolls. You may have to recharge your tolls. You may have a low battery. This is an EV, so you have to charge your battery. So that happens. The vehicle will drive to the nearest battery charging point and charge. You may also have some breakdown, like your headlamp is not working. Then you go to a service center. This is not as easy as it looks, because you are in one network slice which is helping you drive, but you need another network slice to go to the service center. So you need something called, provision a new slice to go to repair your headlight, and then you do that, and then there somebody has to be told which headlight to replace, not somebody, something like a machine. Okay, so it will be integrated with the IoT slice, and then you're on your way. So this is what is expected. The sort of the more, I would say, more closer to you, the application is probably transforming what is called first response, which is how the hospital's doctors, ambulance, comes to you. So this is a big deal, because everyone needs very quick first response and very capable first response, because you have an emergency and you want to act in a few minutes. So you can expect that whatever wearable you have, which is monitoring your heart, your ECG, and so on, will actually be monitored continually by a hospital. So that's the transformation we expect. You're not responsible for monitoring it. A hospital will give you a service, and whatever you're wearing, the health monitoring devices will be monitored remotely by the hospital. So without you having to intervene, the hospital will know that you have a medical emergency. Okay, so the wearable will communicate this emergency to the hospital. An ambulance will be dispatched. The ambulance arrives at your door, and you are carried off to the hospital. Of course, on the way, all your vitals are checked, and the doctor is informed. But when you arrive, the doctor's not there, right? The doctor's probably watching the cricket match on Saturday afternoon, or maybe she's at home, luckily, and she can perform augmented surgery remotely. So this is the promise of 5G, and 5G is being designed to enable applications like this. I will not dwell too much on the rest, but you can sort of extend this to doing remote farming. It's an interesting concept that pretty much if everything is autonomous or even remote, there's a difference between autonomous and remote, right? Autonomous is doing it by itself. Remote is somebody has to control. But even if it is remote, you can farm in Kenya from Delhi. So this could be the new outsourcing wave, because everything is mechanized. So there are sensors which monitor every aspect of the farm, from moisture to crops. You can water or spray pesticides using drones. You can detect intruders. You can do all the other farming activities by autonomous vehicles. So really, things like this are not as far-fetched as you expect. Learning, doing virtual laboratories, being effectively able to teach people remotely. That's also the promise of 5G. Labs are getting virtual. You can, with the things like Google Earth and so on, you can learn geography by actually visiting the places with virtual reality. So I think all these things are changing, and we expect 5G to be the end point of delivering this. Okay. Mining, I won't dwell on this, but a lot of mining, which is a very unsafe activity, can be happened with 5G. Sports stadia are expected to have high resolution video displays, drones. You want to buy some cap or t-shirt, it'll be delivered to you on a drone where you're sitting. So all of this is also expected with 5G networks. Operators are trying to wire up, because this is a very big market to give you a good experience on the stadium. Okay. So these are the applications we envisage for 5G. And in terms of the technical capability that is needed to deliver all these applications, and this is what the ITU envisaged in 2010. They actually set this target in 2010 when 4G was launched, and then they said in 2020 we'll have 5G and everything will go up. So the inner sort of polygon is 4G, the outer polygon is 5G. You may have seen this, but let me explain still what each of these is. So 5G is expected to deliver a peak data rate of 20 gig, whereas it was 1 gig for 4G. You might ask yourself, when did I ever see 1 gig in 4G? That's theoretically possible if you combine all the bands that are available, all the spectrum and so on. So in practice, in 4G, you would have seen 10 meg, which we all have seen, and 5G is expected to take it to 100. Now, spectrum efficiency is, we all are familiar in India with spectrum cost, spectrum allotment, very high cost of spectrum. Carriers have actually been gotten into financial trouble with all these spectrum-related issues. And so making use efficient use of spectrum is an important aspect, and 5G is expected to triple the spectrum efficiency. Speeds, 350 kilometers was supported by 4G. That was fast enough for most of the bullet trains 10 years ago, but now we are targeting 500 kilometers per hour. This is a very niche application. I'll have more to say about this in a minute. Latency. So 4G delivers latency of the order of 10 milliseconds. So it's usually 20, 30 milliseconds. And 5G is expected to take it down by an order of magnitude. We want 10 times more devices. And we are in the era of green. So we want the energy efficiency to go up by a factor of hundreds. We want everything to consume less power. Right? So these were the goals. But in India, some of us in TSDSI said we need one more target. And one more target is that we want rural broadband to be also enabled by 5G. So we said, if these goals are not enough, and we need to have another goal, which is low mobility large cell. Okay? So what it is we said the rural application we have seen is very high speed, right? Because rural in advanced countries is a bullet train speeding through the countryside. So we, on the other hand, have a low mobility scenario where in our rural geographies, people don't go at more than 30 kilometers per hour. Excuse me. So we'd rather trade off speed for having a large cell, and we wanted a cell, the inter-site distance between two cells to be 12 kilometers. We settled for 8 because that would cover most of the areas. If you put one tower, with towers with a spacing of 8 kilometers, that would cover most of the population. And we said we can compromise on speed. So this was a new use case for 5G, which we wanted. We were supported by countries like Nigeria, South Africa, Russia, others with similar needs, but opposed by Korea, Japan, and so on. But finally, we compromised and we said we'll take 6 kilometers. And it was a grueling process. We had to go through ITU for 6 years. ITU first agreed, with 3GPP where we had all the issues. ITU first agreed to make LMLC as a mandatory test case. We submitted something called a radio interface technology, which says how 5GI, we call this 5GI, 5G India or 5G innovative. And we submitted this to the ITU saying this is an alternative. It's actually a modification of 5G. And we said this is the new radio technology, a modified radio technology, which will support this LMLC, the low mobility large cell. The TSGSI made it a national standard. We got the approval from ITU for the RIT. And then I think this is an older slide. I should have updated it, but now it's part of 3GPP release 17. Okay. So this improves better uplink coverage. So what it is that to have a large cell, you can increase the downlink by increasing the power you transmit from the tower. But what you really need to do is be able to increase the mobile phone coverage, the power from the mobile phone, but you're not allowed to increase it. You know, it's only 250 milliwatts. So it has to be limited to that because you can't go around changing phones because people have concerns about power consumption, safety. So you can't say, I'll have a mobile phone which is 500 milliwatts or 1 watt. So we had to play around with the communication technology. We introduced a modulation scheme called 5x2 BPSK, which got better coverage upstream. We did a few other enhancements to improve things, but finally this is part of 5GI, which is now part of 3GPP release 17. And Pamela, as Director General of TSGSI for the last several years, has been at the forefront of getting it through ITU and 3GPP. So I will pause here. I'll invite her to comment on the 5GI journey and also see if there are any interim questions. I've taken less time than I thought I would. And then, of course, I have more to say, but I will continue with that. Over to you, Pamela.
Thank you. So let me see. I think I saw a question popping up. Start my video. Okay. Okay. So yeah, Kumar, that was a very good overview of the exciting use cases that 5G can enable, and specifically why, when looking from India, we had this special use case for rural first, right? So any technology deployment in India, if we are not taking care of the 70% population sitting in the villages, then there's something amiss. And I think that's what played out in ITU. Let me see. There is a question. Maybe we look at these questions first, and I'll then dwell over some of this thing. With 5G ecosystem, with these kind of use cases, what do you feel will be the scope of physical layer security and relaying by reconfigurable intelligent surfaces to enhance security and safeguarding from eavesdropping?
Okay, I will take that question. So 5G actually enhances security at the physical layer. So I think in 4G, the IMSI, right, which identifies your mobile phone, was being transmitted in the clear. In 5G, that is encrypted. So really, at the physical layer, 5G provides better security at the physical layer for user information. In terms of reconfigurable intelligent surfaces, that really is meant to enhance coverage, because in many of these bands, you will have poor coverage, especially inside homes. So you can have these, surfaces, coatings, which will, help with better reflection of the 5G signal and better coverage indoors. In many of the 5G bands, indoor coverage is an issue. So reconfigurable surfaces are really for modifying coverage. Of course, I think the user is getting at the Tarun, that's a question of Tarun there, saying that you could probably reconfigure this surface to get your signal into your neighbor's home or something. But really everything is encrypted, so I don't think that's going to help very much. Yeah, Pamela is going to answer this question, I think. Would you? No, I think you clicked on the button to say answer this question live. That's fine. This question is answered. 5G has lower footprint. I can read that if you want, Pamela. Yeah, you can read. Next question.
Yeah, sure. Go ahead. Go ahead. You can read the question.
5G has lower footprint. Well, 5G will use mostly small cells, and therefore it has, therefore it has a lower footprint per cell, but there will be many more of them, probably along every lamppost. So it's not clear that overall you will have a lower footprint in terms of geographic footprint. In terms of power or energy footprint, that's also not clear. In fact, 5G will probably end up combined across all the sites. Per site, it will be lower because it's transmitting less power, but there are many more of them. So on the whole, I don't think 5G's infrastructure is going to be any lower energy consumption than 4G. Do you want to take the next
Will
question, Kamala?
will the entire 4G network become redundant when we migrate to 5G?
Okay, not at all. I will say a little bit more about how 5G will be introduced and how it will coexist with 4G. In fact, if first introductions of 5G rely on 4G to even operate. That the 5G will not even be standalone. It's something called non-standalone. I'll say more about that in the next few slides.
Will there be an impact on health because of use of millimeter wave?
Okay, so I personally do not think so. Okay, so I think even millimeter waves are not energetic enough to cause any kind of effects like cancer or mutation or something. That requires very high energy electromagnetic waves. We are today in the sort of the microwave band, the 2 gigahertz, 3 gigahertz, same as your microwave oven. You're going to be millimeter wave, but that is not that much higher energy per photon. So I personally don't think there is any danger. However, I'm not the authority on health matters, so you should take an independent view of that.
Yeah, I think there are enough studies that have been done and published on this in terms of myth that this could cause health problems, especially at the powers that are being talked about, power levels. Yes. So cloud gaming needs a lot of bandwidth. So what will be the cost? So it looks like, there are good applications for 5G. So this person is convinced, Mr. Subramaniam is convinced about the need for 5G. He wants to know what will be the cost per, is it going to go down or?
Okay. So cost per gigabyte will go down, okay, because there's a lot more spectrum, and so cost per gigabyte will definitely go down. Your mobile bill is not going to go down because there's a whole game of the tech industry is you get more, but you pay the same because we can't afford to make less revenue year after year, right? The service providers can't. So your bill will not go down, but you get more data for the same. I also want to say that when you're doing gaming or any kind of internet application, you should not really be thinking 4G and 5G, okay? Because a lot of it will happen on fiber-based bandwidth in your home. I think that should be the goal for us as a nation to get fiber everywhere. 5G as a substitute for fiber is only an interim solution. So I think the cheapest cost per gigabyte will actually be with fiber. But with fiber, you can get hundreds of GB a month, which is way more than what your cellular provider provides. They're happy with 1 GB per day, but that's only 30 GB per month. To really have a good experience for your family, you need a few hundred GB. That can only be provided by fiber. So really, if you're thinking low cost per gigabyte, please think fiber, and 5G as only a solution when you can't get fiber, right, on the move, in the car.
So going back to the 5G story, I think it's been a very interesting experience. One is we understood that it has taken us 6 years or more to convince, 4 years to get it in ITU and then another 2 years to get it in 3GPP. Although the traditional thinking is you do something, you take it to 3GPP, you try to get it incorporated. But we found that we need to balance this between the global SDOs, right? So it was a very, very important learning experience that to first go to the user community. So ITU represents kind of the user community and convince them about the use case and get it incorporated in the requirements. Then you can go to the technology community or the vendor community, which is 3GPP, and show them, hey, this is an important use case and let's get serious and incorporate it. So I think this is the learning that there are different roles that the different global SDOs play, and unless we learn the game how it is played, it's like, I always keep saying that if you want to go win the Olympics or win the World Cup, you have to play different matches in different places and you have to learn the rules of the game. And that's essentially just doing some patents and doing innovation and knowing that you need it. But if you really want it to become a reality, there is a different level of engagement in the ecosystem. I think that's a very important learning from that. So back to you. I see a couple more questions here.
I can take them if you want. Yeah.
Okay.
Yeah, so the next question, I'll take the next and you can prepare for the following two. So will 5G networks impact legacy networks? Is there any possibility of risks arising from interference? So the answer is not really. 5G will most likely operate in separate frequency bands. We may end up, refarming some existing bands for 5G. Also 5G and so it will coexist seamlessly, just like 2G, 3G, and 4G have coexisted. So I don't think interference will all be handled by the equipment providers. So I don't think this is a concern.
So then there is this question about whether Tejas is going to provide for 4G switching. I think they mean base stations, 4G base stations and radio for the Indian market before moving to 5G.
The answer is we hope to. You would have seen press reports that we're doing a trial of 4G. Yeah, so that's our goal. We provide 4G base stations and radios first, and then move on to 5G.
Few weeks back, we had a big scare in the aviation industry at the time 5G networks were being deployed in the US. What was the real issue? And why was the FAA and FCC not better coordinated on this?
Okay, that's a good question. Actually, this kind of stuff happens quite a lot. So what it is that, there are different applications which use different frequency bands. So in this case, FAA uses some frequency, which is not the same, of course, but it is nearby. So in principle, there should be no interference because there are two different bands. But there will be no interference to 5G or 4G or whatever you're deploying new equipment, because we would ensure that we filter out the neighboring bands adequately. But the issue here is that legacy equipment, which does not have adequate filtering or adequate rejection of adjacent channels. So you can't go and retrofit everything, and you can argue that they ought to have had a better filtering capability to begin with, because they're all very old equipment. So that's really what it is. And this is not the first time this has happened. This actually happened with, there was a company a few years ago, I think Square One, or the Square was in their name. There's a global company trying to set up a cellular network in a spectrum which was close to the GPS band. It turned out, they were not at fault, but their signals were interfering with GPS, which is widespread use, only because the GPS devices didn't have adequate filtering. But finally, they had to give up that activity because it would have affected GPS, which would be impossible.
So he says 5G schemes to be taking care of all activities, mobility, entertainment. Do we see 6G in the future? If so, in how many years?
Okay, so first, every 10 years there's a new G. That's the mandate. Okay, so we had 3G in 2000. Immediately there was a roadmap for 4G in 2010. It was called IMT Advanced. And then there was IMT 2020, which was 5G in 2020, obviously. And now there's a roadmap to launch 6G in 2030. We don't have a clear idea of what 6G should be. We are setting requirements, like I showed you that spider kind of chart that was set for 5G in 2010 or 2011. And there's something similar, I'm sure, being set for 6G. Maybe we can have another talk on 6G several months down the line. But at this point, that's what we can think of. Everything, all the promise of 5G is not realized, and that's the next half of my talk. And we'll actually be well on the way to 6G before we see everything that I showed you. But there is hope. Okay, so.
Right. So there's already a lot of work happening on 5G Advanced, and there is a thinking in the standards circles that maybe this 10-year thing does not make sense. We need to have many more steps in between. So I think.
So the next question says, thank you, excellent presentation. I just want to tell you that this is only a midterm break. This presentation is supposed to go on till 6:25, so please do stay. Okay.
Access. So maybe we take the rest of the questions later. Let's finish your presentation.
Yeah, why don't we do that? Yeah. Okay.
I think we're getting more technical. So it's good to go through the rest of your presentation and then take these questions.
Yes. So let me go back to my presentation. So Pamela, is this visible properly?
Yes, yes.
Okay,
Yes.
great. Thank you. Okay, so the next thing I want to do is, so this mid portion of the presentation will be slightly more technical. Okay, so let's compare the 4G and 5G technology. So we know what all 5G is supposed to do, and there are these clear goals in terms of high bit rate, low latency, and so on. So let's just compare 4G and 5G in a couple of slides. You know, what's different? So in terms of operating frequency, all your 4G networks today operate below 3.5 gigahertz, you know, mostly below 2.6. Right, so a lot of the spectrum in India, bands in use are, you know, 900 megahertz, 1800, 2100, and 23 or 2600. So these are the bands. Now, since all of these are occupied, 5G will operate in different bands. So the initial bands will be around 3.5 gigahertz. It's called N77, N78. N in all of 5G stands for new, because 5G is simply called new radio. So, and there are two distinct sets of bands. One is what is called frequency range 1 or FR1, which is everything below 7 gigahertz. Used to be below 6 gigahertz until a few months ago. And then I think somebody said we can do 6.1, 6.2, something. Then FR2, which is what is called millimeter wave, which is, you know, 24 to 70 gigahertz. And since somebody already started 6G, 6G is 100 to 300 gigahertz. Now, there is no fundamental advance, in my view, in modulation or in the underlying communication technology for 5G compared to 4G. So this is quite different from what happened from 2G to 3G to 4G, or even 1G to 2G. So 1G was analog, 2G was digital, which was a significant improvement in quality and so on. 3G was CDMA, two different flavors, but essentially all CDMA, which also was very good for voice quality and a fundamentally different communication scheme. 4G was OFDM, so was WiMAX actually. And that's again a dramatic shift from the previous generation of technology at the physical layer level, the communication level. In 5G, there is no such shift. It's essentially the same technology. I actually had minor differences, but I figured it wasn't material. It's really the same technology underlying. Modulation schemes go up to, you know, used to go up to 64 QAM in the first releases of 4G, but 4G Advanced also allows 256 QAM. I assume you know 256 QAM, what it is. Otherwise, nowadays there's a standard way. If you don't know something, Google it. That tells you enough in Wikipedia. 5x2 BPSK is the technology introduced in 5Gi in order to you know, increase the cell radius and get better uplink coverage. There are some changes in the error correcting codes. 4G uses turbo codes, whereas 5G uses a mix of various kinds of codes, LDPC, I think that's low density parity check codes for data, polar codes, Reed-Miller codes for control channel reliability. There is one more trend which I only mentioned because it's the key to low latency. So in this orthogonal frequency division multiplexing, you have many different subcarriers. You know, carriers. So it's not one carrier frequency, but subcarriers, which are all 15 kilohertz spaced. In 5G, this subcarrier spacing can be 15, 30, all the way up to 240 kilohertz. And that actually is the key to low latency. If you use a high subcarrier frequency, then your time slot gets reduced proportionally, and you get a much lower latency. So that's really the key in 5G, to get a much lower latency than what you get in 4G. Now, you get your throughput gains by just, since there's no real gain in terms of modulation. You can see 256 QAM. You can say 4G is 64 QAM, but 4G can also do 256 QAM today with 4G Advanced. So real gains of data rate in 5G come from throwing a lot more bandwidth at it, okay? So 20 megahertz versus 100 or 400 megahertz. Subcarrier spacing, SCS is subcarrier spacing. So 4G had TDD, FDD, 5G has more complex schemes. The bandwidth is only, so 4G, you could do a maximum of 20 megahertz in one band. Of course, there was a technology called carrier aggregation where you could put together multiple bands, and that way you could scale. In 5G, you can do, in the first release of 5G, you can do 100 megahertz per band, and then you can do carrier aggregation. On the receiver side, you know, 100 megahertz is a lot of bandwidth for your every low-end mobile phone or IoT device to support. So 5G as a technology where the device can say, I don't support 100 megahertz, but I support, just this portion of it, 1/4 of it, 25 megahertz, and you have to address me in this portion of the bandwidth only. So 5G does that in order to reduce the cost of the device. Otherwise, devices have to support the full band. That's not true in 4G. In 4G, if your phone supports a band, it has to support the full 20 megahertz. Another way in which 5G can increase spectral efficiency, though I think it's not yet done, it's not part of the current release, is full duplex, which means you use the same spectrum band for transmit and receive. And this is not part of any 4G release, but is potentially possible with 5G. I'll have more to say about dual connectivity in a minute. Okay, so this I kind of briefly explained. So what you can do with 5G is that user equipment can have different bandwidth parts. There can be 4 downlink, 4 uplink bandwidth parts. Only one is active at a time. So in principle, a device, especially a low-cost IoT device, can say that it will only support a part of the bandwidth. This is basically done to reduce the cost of devices, reduce their energy consumption, because you don't have to operate in the full bandwidth and so on. There is one more aspect of 5G which is interesting, which is massive MIMO. So FD MIMO is full dimensional MIMO. So today in 4G you have 4x4 MIMO, which means you have 4 antennas for transmit, 4 antennas for receive. The best mobile phones also have that, but usually the mobile phones are 2T, 2R, 2 transmit, 2 receive antennas. In 5G, you can have a big antenna array, especially in FR2. FR2 is the millimeter wave band, which is from 24 gigahertz upwards. So those wavelengths are smaller because the frequencies are higher. There's an inverse relationship, as you know, between wavelength and frequency. So you can actually build massive antenna arrays because of the millimeter in millimeter wave is the wavelength, though it's really much more than a millimeter, but it's measured in millimeters. So you can build antenna arrays, and if you have many antennas, you can sort of adjust the phase of the signals coming out of them to form a beam, and you can use a beam to address a mobile. Okay, so the idea here is that you can have different beams addressing different users at the same time. This sounds horrendously complicated, and it is. But you may already, you should appreciate that already in 4G, the base station is doing things which are very specific to each user, each mobile. You get band, you get allotted. Of course, you're told what should be your timing advance, your delay in transmission, because you adjust for different people being at different distances. The user measures the channel quality. Based on the channel quality feedback, every user is given a different modulation and coding scheme. So in reality, already in 4G, every user is being independently managed in a very complex manner to get the optimum performance. So 5G with beamforming takes it one step further in terms of giving you a dedicated beam that is directed at you. But a lot of the problems here have to do with keeping the beam to track you and selectivity of the beam and so on. So I kind of explained it without the bullets, but you can have a narrow beam. If you have a narrow beam, then you get a higher quality signal, which can go further, and therefore you can get a larger cell. And you can do spatial multiplexing, which means you use the same frequencies, in different points in space around the cell. So it gives you higher capacity. Okay, so that's the promise of 5G and how it compares with 4G. So what is the status of 5G? So 5G is launched in a number of regions. So I earlier showed you a slide similar that was only for fixed wireless access. So 5G is launched, I can't count here, but 100 plus operators around the world. This is one source, which is Omdia. We don't have 5G yet in India. I from another source found that if you include all the trial networks, there are 196 5G operators with 95,000 sites for 5G being deployed. India shows up on this map because we have a trial network in India, and then Sri Lanka shows up. And these networks are expected to cover something like 90% of the population in China and about 45% of the population in the US. So 5G deployments are well underway. Somebody asked a question, will 5G cost more, 5G reduce the price and so on. So the market for 5G, the total market for 5G, the RAN market, is more or less constant, $35 billion a year. But 5G will grow at the expense of 4G. So today in 2022, you have there is a 5G market and revenue, there is 4G and so on. So maybe this is skewed worldwide, or the people count the networks where there is 5G available as 5G. I don't know if this has grown so much, but anyway, this is one of the sources is Omdia. So 5G is expected to grow at the expense of 4G, but our total bill should remain the same because we're not going to pay more. There's another question, which is, will 5G coexist with 4G? So the answer is definitely yes. In fact, the initial deployment of 5G depends on the availability of 4G. So 5G will be initially deployed in something called non-standalone mode. Okay, so it will be initially deployed in dense urban areas because that's where you have paying customers will pay more for the 5G service to get better bandwidth. But the connection will actually be set up by the 4G network. So the mobile will connect for control. So the dash line, I think, is control for both blue and red. So it will connect to the 4G network. And then the 4G network, in turn, if you have high-speed data download, will tell you to connect to the 5G network. It's kind of like a handover, if you will. But it's different from a handover because you have two radios. So the 5G mobiles are capable of being connected to two different networks, one 4G and one 5G. And this goes by the, I haven't put the acronym here, it is called ENDC. It's good to understand acronyms sometimes. E in ENDC is EU-TRAN. EU-TRAN is the geeky name for 4G. N is new radio, which is the name for 5G, and DC is dual connectivity. So 5G supports ENDC, so that is dual simultaneous connectivity, both 4G and 5G, so you can keep both of them on. So that's one of the significant changes in your 5G mobile, which will give you a much better experience. Actually, I didn't mention this. With this kind of connectivity, 5G will also enable you to make before break. So when you hand over, when you go from one cell to another, usually you have to break and then make because you only have one radio. But here you can make before you break because you have two radios. Okay, so 5G can do cooler things, give you a better experience. In standalone mode, 5G, your mobile will connect to 5G directly without having to go through the 4G network. So 5G is evolving. Someone asked, are we going to 6G and so on? So 5G, release 15 is considered the start of 5G. I think release 15 happened somewhere in 2021 or in 2019. Since then, we've had release 16 and release 17. So those are all still considered 5G. And release 18 is expected, the work on release 18 is expected to start soon. And that will be 5G advanced. So we have to do releases every year. We have to go to standards meetings to make a living. We have to introduce new equipment. So typically the goal is to have a release every year. I think that was the idea, if I'm not mistaken. Except we have slipped a little bit. So in 22, instead of release 22, we are release 18. And by the time around release 27, 28, we should be in 6G. So if you look at 5G and all the application size, there was 5G technology started a few years ago. So now we have a lot of expectations from 5G. It's supposed to digitalize the country. It's supposed to give you all these cool applications, which I listed at the beginning of my talk. We are all waiting with bated breath. We bought 5G phones. If you bought a phone in 2021, it's almost certain that you bought a 5G phone because in the Indian market, 5G phones started to come, I think, in November 2020, if I'm not mistaken. So if you refreshed the phones for yourself and your family in 2021, you already have a 5G phone and you're waiting for all these cool applications. But maybe you won't get all of them. So let me go through what is the reality today on 5G. So first, you got your new phone and you expect blazingly fast internet from 5G. So first one I want to disillusion you is in 2022, when you get 5G in India, you will get pretty much the same quality of internet that you get on 4G. 4G itself, when upgraded to 256 QAM, will support the same modulation schemes and the same capacity as 5G. The high speed of 5G is only possible because you give it more bandwidth. So if you do get, let's say, if each carrier gets 60 megahertz of bandwidth or something like that in 3.5 gigahertz, potentially they could give you 3 times the capacity, 3 times the speed. And if there are fewer users, you will get faster internet, but it's not going to be blindingly fast. And the allocation of spectrum is taking place a little slowly because there are other agencies, Space and Prasar Bharati, who are using the spectrum. So a lot of bandwidth can be allotted only after these coexistence studies can be completed, so that we don't land into an FAA, FCC kind of problem that one of the viewers asked, right? I think Siddharth asked that question. We also have are using a lot of these bands. I actually have a slide coming up later where these bands are being used for a lot of satellite applications. The potential 5G bands are used for a lot of satellite applications, direct to the home and so on. So we don't have a lot of spectrum to spare for 5G. Okay? And lastly, even if there's a lot of spectrum, you have to have an expensive phone which can access all of that spectrum for you to get that speed. If you have a lower cost 5G phone, it will use this bandwidth parts. So it will only support 20 megahertz, not the full 100 megahertz. So you will only get 4G light speed. So all of this you have to bear in mind. The last, it's an important point, is that at these rates, 5G needs fiber backhaul. 5G definitely needs fiber backhaul for the bit rates it's talking about. So microwave-based backhaul will not work. But today, a lot of the 4G networks are backhauled with microwave. So fiber does not reach more than 30% of the base stations. So that will actually be a stumbling block for 5G deployments, because even though you may get capacity on the access side, between the mobile phone and the 5G base station, how are you going to get enough backhaul capacity from the 5G base station to the internet? So that's also an issue. Okay, so 5G will take off. So in conclusion, you will get slightly better speed, especially when you're closer to the base station, but that's about it. It's not going to be 10 times faster. The next one is that there are going to be drones and cars and self-driving and everything connecting to 5G. That will happen. Everything I'm saying will happen over time, but it's not going to happen in 2022, and that's the point. So the most advanced electric vehicles today still use Bluetooth. Okay? And to fulfill the promise of drones and cars connecting to 5G, you need to deploy 5G base stations along all the roads. So you must have pervasive coverage, right? You can't have a coverage drop. If you're going to drive a car, you can't say I have no coverage, and what does a car do, right? You can't drive itself. So you must have very reliable, continuous coverage before you can start doing all these autonomous vehicles, whether it be cars or be drones. So the V2X application, the V2X is vehicle to YX. It can be vehicle to vehicle, V2V, or vehicle to infrastructure, V2I. And the infrastructure is base stations along the road. V2E is cars talking to cars. So the infrastructure is 5G, and that is not going to happen till all the roads are 5G base stations, and that's going to take a few years. Okay. So eventually, drones will connect. Drones today use Wi-Fi. But drones will eventually, there will be lanes with 5G base stations, and drones will connect to 5G base stations and will be controlled, and the flight path will be dictated by 5G, but that is several years away. Also, ground and drone. So today, all base stations, whether it be 4G or 5G, aim for users on the ground. So their antennas are tilted downwards towards you in the car. Right? If there are drones, they probably, depending on how high the drone is, you probably need a slightly different deployment to cover the drones, which now are higher up in the sky. Okay. So there's a lot of investment needed in things like putting 5G base stations along the roadside, and for telecom service providers, that's TSPs, to support these applications on 5G. Okay. in terms of bandwidth, is there enough spectrum in India? So the short answer is there is not enough spectrum. But let's look at where the spectrum is used. That's sort of instructive in its own way. So 700 megahertz or band 28 is widely talked about, but telecom service providers find this too expensive. So they're not buying this spectrum. So some of it is allotted to railways, but otherwise the spectrum is available, but too expensive to purchase. 900 megahertz or 850 megahertz is band 5. It is used for VoLTE by many operators due to better coverage. Band 8, which is 900 megahertz, is used for 2G, and some operators use it for 4G, but a lot of 2G happens in 900 megahertz. 1800 megahertz is a 4G band, so there are deployments of 4G there. So, but spectrum is clearly not available for 5G, because 4G is going to go for a long time. 2100 used to be where 3G operated, it's now being migrated to 4G. 2300 is widely used by 4G pan-India, and so is 2600. A part of 2600 is also used for ISRO, okay, and only 40 megahertz is available for 4G. IMT is 4G. And 3300, 3600, what is called N78, is the most popular 5G band, the sub 6 gigahertz or FR1. ISRO uses this band partly, so we have to resolve a lot of coexistence issues because you don't want to interfere with the satellite receivers and so on, which are actually very sensitive because they receive low power signals, and 5G can interfere with them if deployed in this band. So there are coexistence studies that are needed. Similarly, in the millimeter wave band, 24 to 28 gigahertz, there are coexistence issues, and of course this band has very poor indoor coverage. 25 gigahertz does not come into your home. So getting adequate usable spectrum is a challenge for 5G, before you can meet the promise of 5G. So this large bandwidth, except N78, that portion is reasonably clear that about a couple of hundred megahertz, give or take, is available in that spectrum and in that band, and there will be an allotment after an auction. Okay. Latency. So in order to realize the low latency of 5G, 5G has to use this larger subcarriers, 30, and also in millimeter wave, you use 240 kilohertz subcarriers in order to really get the promise of 5G. If you're just using 15 or even 30 kilohertz subcarriers, you are only going to get latency comparable to 4G. So these are some tests. The median 5G latency for all 5G phones is about 30 milliseconds, which is the same as the 4G latency. So you need phones which really support many slots. The network has to support many slots to get this 5G latency. So in 2022, if you buy your 5G phone, you're not going to get the lower latency, which allows you to game better or whatever. Energy efficiency, this is also a question. So, even if you're doing massive MIMO, if you're doing 60/40, 64R, the per antenna power may be less, 5 watts or 2-3 watts, and less than that. But the total radiated power will be a couple of hundred watts. This compares to the radiated power today, or actually is a little bit higher than what you get with 4G and so on. So 4G can do 2 by 40 watts, 4 by 40 watts, but really it's not 40 watts all the time. So 100, 200 100 watts, give or take, it's radiated power today by 4G base station. 5G will radiate 200, which is in the same ballpark, a little bit higher. Okay, and if you have 200 watts per sector, even if your power amplifiers are very efficient, you will end up for 600 watts consuming actually more than a kilowatt till newer power amplifier technologies come in. So 5G base stations are not going to consume less power, at least to begin with. Okay. You also need a lot more base stations because you need a lot more 4G base stations compared to 2G. So 2G 900 megahertz base stations could cover the intersite distances were 2-3 kilometers. Whereas with 4G, it's more like less than a kilometer. So because 4G operates in 1800 or 2100, which is more than twice the frequency, 5G operates in 3.5 gigahertz. So that will have even less coverage. You will need more base stations. Okay. So it's not clear that 5G will be viable, and I think this is a study for operators, actually, especially massive MIMO. So 5G may get deployed exactly like 4G without all these fancy features of beamforming and so on, because you have a massive cost on the equipment, plus you have an operating cost due to the power consumption, and people are not going to pay you more. So you may get 10% more ARPU. So with this, so whether 5G will end up doing all these fancy beamforming and so on depends on whether it is cost effective. Traffic density of 5G, really this is gated by fiber backhaul. So you can increase the traffic density only by having a lot more base stations, but to have a lot more base stations, you need to backhaul them. With only 30% of the current base stations having fiber connectivity, it's not clear how you backhaul them, right? Because pulling fiber takes time. Digging in cities is not easy. You might not think that given how often we see roads being dug, but actually it is an expensive process. So you have to rely on wireless backhaul. So small cell sites can be backhauled with microwave. They can be backhauled with EV band, which is like the 760, 70 gigahertz bands, or they can be backhauled by FTTX. FTTX is fiber to the home. This is GPON. So homes are reached by fiber, so the street is presumably reached by the same fiber, and you can backhaul small cells using that technology. But microwave backhaul is already occupied for backhauling 4G, and E-band and V-band, there are licensing issues. So they're potentially licensed bands. They may need to be allotted through auctions. So the regulatory environment around 60, 70 gigahertz E and V band is not clear, okay? And for FTTX to backhaul small cells, FTTX today is operating at 2.5 gig, which is not enough, 2.5 gigabits per second, right? So, but it's not good enough. You need 10 gig PON or a combination of 10 gig and 2.5 gig PON to support 5G small cells. So backhaul is standing in the way of deploying more 5G cells. Security, somebody asked this question. Actually, 5G security is better than 4G at the physical layer. So you use permanent identifier. Your mobile phone has something called an IMSI, which is a number which is permanently associated with your mobile. It's never sent as clear text, unlike in 4G. So 5G is inherently better at security. But the concerns with 5G have to do not with something like eavesdropping, but it's more to do with equipment, especially base station infrastructure equipment, having Trojans, malwares, which can be remotely enabled, right, during a cyber attack. So now, right now, we're all very much aware of wars, Russia, Ukraine. So can somebody turn off your network, in the case of a war, which can disrupt the whole network, whole economy. So most of the security concerns have to do with the fact that networks can be remotely attacked with malware or turned off. So you need trusted ecosystems for suppliers, right? So India has initiated a trusted ecosystem, a trusted equipment vendors initiative. So you got to go and register yourself and be told or being given a trusted certificate before you can sell infrastructure equipment. So that is coming up. So essentially, security concerns have to do with trusting the equipment rather than things like eavesdropping. Okay. So then the last myth, and after this I'll take questions, is 5G is open. And when you say open source, the first thing that comes to mind is 5G is like Linux. So I want to tell you 5G is not exactly like Linux, though it is trying to be. So first is, 5G, so there is, what happens on your PC is your hardware and software are disaggregated, right? So you buy your hardware from Intel or AMD and your software from Microsoft or Red Hat, okay? So that is the promise. So this disaggregation of hardware and software, which is not true for telecom equipment, you buy everything from the same vendor. So expect to start from 5G, okay? But it's hard to run 5G on a general purpose COT server. Like general purpose COT server is COTS is commercial, off the shelf, right? So this is like buying an Intel-based server and running 5G. Okay, so that is what many people are trying to do, but there are several limitations. So what is standardized now is the open interfaces, right, between the hardware and the software. But there are many optional features, and if you want to work efficiently, you have to use all of those optional features, and especially for interworking between vendors. So they are not opened up by the established players. So while there are many open initiatives starting up, it will be hard to beat custom-built hardware and custom-built software in terms of cost, efficiency, horsepower, and so on. Okay, so I have many bullets here. There are multiple Open RAN initiatives. Some of them are also running into trouble because of, you're still bound by something called FRAND, right? FRAND is fair, reasonable, and non-discriminatory access for the essential IPR, for the standard essential IPR. So Open RAN does not relieve you of many of those obligations because the patents still stay. Okay. Now there is the US-Chinese problem. So can Chinese companies be part of Open RAN coalitions? Right? If they're part of it and they're subject to sanctions, then how do you operate? So open initiatives are there. They're trying to do multiple things. They're trying to standardize interfaces. They're also trying to disaggregate hardware and software. They're trying to run software in the cloud, but it's also not clear that you want to run the software for a base station on the cloud. Maybe other parts of the software, yes, but probably the software for the base station is better off running at the bottom of the tower. Okay, so 5G open is an open question. It's not really as open like the Linux you use. You can explore this separately later on. Okay, but I want to leave this thought with you that 5G is trying to be open. It's not yet there the same way as computing. Let me conclude this slide, and then we can do a few more questions before we wrap up. Okay, so 5G. So I've sort of hyped up at the beginning and then brought you down to earth at the end. I want to conclude by saying 5G is a promising technology. It will eventually provide us much better internet access. Not only us, it will also provide all the machines, the things around us, pretty much on the lines of what I started with, but it's not going to happen in 2022 because today it's overhyped. Any technology gets overhyped early on. So 5G has limitations, many practical issues to overcome. But then we'll go through disillusionment in 2023, and then slowly we will climb the slope of enlightenment. I really like the Gartner chart. And then things will get better and we'll do this. So eventually, 5G will lighten our chores, do a lot of the things that it promised. And supposedly all this technology is supposed to give us even more leisure, okay? But I can tell you with all this technology at disposal, I'm not finding any more leisure. I'm actually finding more work. But that's what they're supposed to do. They're supposed to do everything by themselves, remotely, autonomously. But somehow we seem to find more work to fill the gap. Lastly, I want to leave you with this. Everything we think that 5G will do is probably wrong, in the sense that there will be a killer app for 5G, which we don't know today. And this is historically correct, okay? So 2G was just about digitizing voice. But what was the killer app in 2G? It was SMS. Imagine life without OTP, okay? You couldn't do anything. 3G was, what was 3G for? Okay, so 3G was for, I think, better coverage, better interference management, some other goals. But what 3G did was enable email on your mobile. 3G was the era when BlackBerry flourished. So when 3G was conceived, nobody really thought of email. Just like when 2G was conceived, nobody really thought of SMS. When 4G was conceived, 4G was all about all IP networks and so on. Okay. Of course, there was a brand new modulation scheme which promised much better capacity. But what revolutionized 4G was smartphones. And that's not part of the 4G standard. That just happened. Steve Jobs, Apple, we have to thank, and then others who followed. So smartphone and apps totally revolutionized our life. So similarly, when we started doing 5G, we thought of all these things that I presented at the beginning. But probably something else will happen that will dramatically take advantage of the capability of 5G networks, maybe the low latency, maybe the large Internet of Things. And that will change our life in ways that we don't know, right? So, I mean, imagine 10 years ago, we're not using Google navigation. 25 years ago, we didn't have web browsing, or we didn't have Google search. I remember those days, there was no web browsing. But things have changed so much that we can't even recognize life. So 5G may do that. So on that positive note, I want to end this talk. I also would like to thank Jishnu in my team who prepared this talk for me. So thank you, Jishnu. I'll stop the sharing and hand over to Pamela for Q&A.
Yeah, so there are a lot of interesting questions out there, and maybe we'll not go in order. I would pick this question: what would be your opinion of 5G bringing up dissemination of networks by new radio-based slicing, which give birth to multiple use cases of EMBB, URLLC, and MMTC, which was not as segregated as previous Gs? Does that bring differentiated quality of service and business model? So basically, the verticalization and the vertical businesses, I think.
So the short answer is yes. 5G is going to support all these applications with better QoS. Really, in one word, the promise of 5G is reliability. Okay, it's not really higher data rate, but probably more reliability. So you can get coverage, you can cover your Internet of Things, your device in your basement, and if you are driving, you can get guaranteed bandwidth. So really 5G has to do with all this network slicing, a guaranteed QoS end-to-end. We need it end-to-end because you can't say the rest of the network dropped, it was not 5G. So this end-to-end slice for the application, guaranteeing all the QoS parameters, bandwidth, as well as latency, is the promise of 5G. And I think 5G will live up to it. Not immediately, but in a few years, yes.
There's another more user application space. Then there are a lot of deployment questions. So war with weapons and digital war. What does 5G? I think war is there on everybody's mind.
Well, I think the worry about everything that we have today in networks, not only telecom networks, power networks, and so on, is that somebody could attack them, shut it down in terms of a war, malware, and so on. So that is actually the heightened security. So so the people in charge are worried about keeping the network secure, because the expectation is 5G will be prevalent, right? Everywhere, everything will be connected through 5G. So anything happens, it's not like your mobile phone goes down and you can take up a landline. So that's the worry. There are no easy answers. One answer is looking inward and building own trusted equipment, but that's not possible for all countries, right? So the world may divide into different trusted islands. So something like that will happen.
Yeah, right. And I think some of this NTN can address some of the big challenges. We remember in one of our conferences, these guys from Afghanistan came and we said, what is your biggest challenge? They said, we have a security challenge. And we said, what's a security challenge? He says, the guys just bomb our base stations. So what can you do about that? And I think somewhere if the base stations are, you can have them on the ground, or you can have them in the satellite, or you can have them in a drone. I guess something like that has to be thought about, especially from a war.
Because there are many, so you curate it, and I will answer whatever you think.
Okay, so I think there are a lot of deployment questions now, starting with fiberization. With fiberization not being there, what is India's plan for 5G?
Rana, I can do that.
Yeah, maybe you can go ahead and pick.
So India is lacking fiberization. Will it affect India's plan on 5G deployment? Certainly. 5G, fiber backhaul is an essential requirement for 5G. So we have to quickly figure out how to get more fiber to all the base stations that we plan to deploy. Otherwise, we can't deploy more 5G base stations. Sounds like satellite-based connectivity will not work for 5G. That's correct. I think 5G requires terrestrial-based connectivity. That's not going to work. The need for large base stations, practically ubiquitous, and pose serious challenge for deployment. One challenge being the access in public base stations, public spaces. So the answer is correct, that is 5G requires a lot more base stations, but they will be small. So hopefully they can be, the thinking broadly is they can go on lampposts and so on. So they don't need a tall tower because they're not really trying to cover a lot of distance. So that way it may be more livable. One more question is, why does the coverage fall with bandwidth? That's the physics, you know. So I think there is a inverse relationship between the wavelength and the propagation through terrain. So that's just a physics. I don't know what the further physics behind it is. You can look it up. But yes, it is. There's a physics fact that propagation just falls off. Higher the wavelength, you know, the faster the decrease in power. So India should not buy Chinese equipment for 5G. That's kind of the thinking, that people don't buy equipment from countries that they don't trust because there is this fear that it can be turned off. So that's the current thinking. I don't set the policy for the country, but that's what it is. The other question is there any scope for access point antenna designs in the Indian market? I think there is scope for every part of the technology. Access point antenna, I assume you mean something like 5G access point, Wi-Fi access point. But if you know, there are vendors coming up, especially because of government scheme like, you know, private PLI, you know, production linked incentive. So there are equipment makers of all sorts trying to make equipment in India and then indigenize. I think you should team up with some of those equipment makers if you're doing one aspect like access point, like antenna design. Are there any working pilot deployments of 5G? I assume the question means, are there working pilot deployments of 5G? I think the government made available test spectrum to all the operators, and the operators chose vendors to do 5G deployment. So there are almost all operators are testing 5G for applications and so on today. Okay, I have only one more question. With IoT, with many IoT connectivity solutions like LoRa, WAN, NB-IoT, LTE-M, Sigfox, where does 5G stand as a differentiator for IoT specifics, and would that be better? Okay, so there are IoT technologies which are from the cellular world and the non-cellular world. Like LoRaWAN and Sigfox are not from the cellular world, right? So that requires a parallel deployment of infrastructure, base stations, and so on. So I think there's effectively a starting handicap for all of those technologies because, you know, you need effectively mobile-like coverage, you know, sites. So I think technologies like NB-IoT, which is part of 4G, and LTE-M, which is also part of 4G, but probably not as popular. I think LTE-M is targeted for higher speeds, NB-IoT for lower speed applications. They have a better chance of success because they can ride on the mobile infrastructure, and NB-IoT is only like a software add-on to the base station. So I think they stand a much better chance. And 5G will take that forward, you know, because it's a cellular technology. So I think 4G technologies like NB-IoT, and then moving on to their equivalents in 5G, has a much better chance of success for IoT coverage. There's one more question. Wireless backhaul devices or technology could be replacement for fiber. So this is a good question, and many people are seized of this. So traditionally it has been that microwave backhaul, so when say wireless, it depends on which band, right? So microwave backhaul, which is 11 gigahertz, 28 gigahertz, all of those bands are being used heavily for 4G backhaul today. Since those bands are all occupied, and some of those bands like 26 gigahertz are also competing for access, right, for the mobile phone to use the 5G network. Wireless backhaul has to move to higher bands. So in higher bands, which is now 60 and 70 gigahertz, the licensing regulatory regime has to be made clear. Plus, you have issues of rain in at least one of those bands. Both of them have, I think, issues to some degree. One of them is worse. I can't remember which. So you have to solve those problems. People are talking free space optical, but again, free space optical suffers a lot from obstructions and so on. So wireless can be a replacement for fiber, especially for short distances, and E and V band are the most promising. But I think we have to solve some regulatory hassles of how this spectrum is going to be auctioned before we can deploy it effectively. Okay.
5G versus 5GI. Where will India? What will India adopt?
Pamela, you can take that question.
So basically, now that 5GI is converging with 3GPP at 3GPP, so it's going to be part of the 3GPP 5G, with release 17. So our hope is that 5GI will become an integral part of 5G, and you will get, that additional pi by 2 BPSK with spread spectrum, that waveform will be there, to give you rural connectivity. So the same base station will be able to serve both 5G and 5G with UE without a 5GI and as well as with a 5. It's a good comparison that I like to give is dual SIM. So if you have a dual in India, you buy a dual SIM phone, but if you go elsewhere, they don't support dual SIM. It works there, but when you come here, it works. So I guess that's what we are hoping will happen. Yeah. So there is what is the capex required for full-blown 5G? Does NSA going to stay much longer than SA?
So the answer is, the question is, what's the capex required? Is NSA going to be prevalent? The purpose of NSA is that you work with the 4G EPC, so you don't need an EPC upgrade. Because EPC is the mobile core for 4G. So you just add 5G base stations kind of below the 4G, right, like small cells. So I think that makes the deployment of 5G, the initial deployment of 5G much more cost effective. So the answer is that NSA will require you to add 5G base stations, and hopefully, and then the operators have to do their business case, that these will give them more traffic, more users, and therefore make it viable for them.
How can non-mobile service providers provide 5G services?
I don't have an answer to that. I think this whole thing is geared to mobile service providers. Okay, but there are some interesting thoughts in this direction. So I think Mexico did an experiment. I don't know how successful it was, of saying a neutral provider, a neutral infrastructure provider will build the 5G network. Okay, and then other service provider, they can all ride on this. It's like service providers become like OTTs. You don't have to build your own. So it is already there for towers, right? So towers are all shared. Fiber backhaul is shared. You can take this one step further and say radio is shared. So radio is on common spectrum, and what the mobile provider does is marketing. You buy the service from him, and then he promises good service, maybe takes care of other aspects, but does not necessarily have to build it's a virtual service provider. And in that case, doesn't have to be a mobile. Somebody can be a fixed wireless 5G provider. So it is possible. There was an experiment, I remember, in Mexico. You can probably Google it, but I don't know if it's gone further than that.
So there is going to be the shakeout of the ISPs and the TSPs, the convergence happening and the roles getting slightly redefined. I think it's going to play out interestingly.
Pamela, we will stop. I'll make one concluding remark taking off on your thing, and then we will hand it off to Sushila. So there's this convergence, TSPs, ISPs, OTTs, and all that, right? So I think ISPs have a role independent of TSPs are now ISPs, because what is telecom? Telecom is really internet service, right? So I think that merger will happen. But the interesting question is what happens to these OTTs versus telecom service providers, right? Because they've traditionally been seen as competitors, because you can do WhatsApp call or you can do OTT call, right? So I think the OTTs will end up being the biggest customers of the telcos, because the OTTs, which will now include things like hospitals and so on, will start to use the telco network, and you will actually pay the OTT for the service. So take any of these health applications. If the hospital is remotely monitoring your health, pick your favorite hospital, they will pay the bandwidth charges to all the service providers whose networks you're roaming, because they are providing the service. So similar things you can happen to all the OTTs today, that you actually pay the OTT for the service, and then the OTTs will in turn give you the service by using the telco service provider networks. I think those things will start to happen, and that could be a smooth, what should I say, coexistence of OTTs and TSPs and so on, with OTTs being the customers of the TSPs. So maybe it is close to 6:25, so maybe we stop here. Pamela, you have concluding remarks from you, and then you can go to Sushi.
Well, thank you very much. I think it was an excellent presentation, and all the enthusiasm from the audience, you know, is a testimony of how excited everybody is. And I expect that the research and the entrepreneurial community in this talk will get more and more engaged in the 5G and 5G beyond journey. And we at TSDSI are very happy to welcome you and take you down this path. So handing it over to Sushila.
Yeah, thank you very much. Yeah, this was really a very exciting talk, and Kumar, I must thank you for a very fact-filled but extremely interesting talk. I think you did cover a very wide range of topics around 5G, and thank you very much for all of that. Pamela, we could not have asked for a better moderator for this session, with all the experience that you bring to the table, and thank you also very much. So I'll just summarize, sorry, please.
There are a few unanswered questions, Kumar. How do you want to handle those?
No, I think 6:27 we end, so we'll go to Sushila.
I think this discussion can go on forever, but so I just want to summarize some of the key takeaways from today. We started by looking at Kumar telling us that as our desire for instant gratification keeps increasing, as we expect work and education to go more and more online, as factories start to run autonomously in the future, for all of this to become real, reliable connectivity is absolutely paramount. And that's where 5G fits in. Private networks, which again is what will be required to make things like applications like autonomous vehicles work, again needs 5G. And where we are not able to get reliable fiber to, because of various reasons in a country such as ours, 5G will play the role of making sure that everybody is connected. We started by saying that the first thing that's going to happen is providing fixed wireless access, and that is what that is where we are at across the world today. Kumar then talked us through what does 5G really promise us. It's things like when you have bullet trains running at 500 kilometers per hour, we will have reliable network connectivity. It is designed not just for the population, but for much more than the population. In other words, the Internet of Things, sensors, meters, all of that. It is designed for high reliability and coverage and guaranteed quality of service and bandwidth and latency. That is what the standard is really designed for. We saw some fascinating examples, the first responder example, autonomous driving across states, augmented surgeries, remote farm management. All of this can happen from anywhere to anywhere in the world in the future. Kumar then talked us through the standards, the 5 layers that form the basis of 5G, and then talked us also through what is important for India when it comes to the standards, and how through the efforts of TDSI, we've been able to add the specific issues that are required for low mobility, large cells, which is really what is required for our rural first philosophy. And ITU, through the efforts of TDSI, has approved the 5G standards. There is still much work to be done to make that real, but at least we've got the standards in place. He then talked about the technology underlying 5G and the differences between and improvements between 5G and 4G. Specifically 2 points, full duplex is possible, and the massive MIMO antenna arrays, which is how the scaling can happen. Globally, there are a number of deployments already in place. The way 5G is going to be deployed is starting with dense urban areas. It is going to use 5G for connectivity at the back. We are at the, and then he presented the 5G hype cycle, and we are right at the peak of inflated expectations. So from here, it's going to be very downhill before we start seeing some reality happen. He then presented 8 myths, and I'm just going to call out a few learnings from that rather than the myths themselves. The first thing is that we need a very, very large bandwidth. For us in India today, to be able to get to that point, we are going to have to also do things like coexistence studies between the many agencies that are using whatever bandwidth is available to us today. Much more fiber backhaul is going to be required. There's going to be work required on things like technology of power amps, etc. But the regulatory environment we will need to look at. And of course, there's going to be the need for many, many, many more base stations before those fancy applications of drones and autonomous vehicles are even going to be remotely possible. We also understood a lot of facts about 5G security and the how of it. And then the last issue there was how open, or what is really open when it comes to 5G. We ended by Kumar telling us that the promise is very real, but it's going to take a lot of time for us to get there. And very interestingly, we still do not know what the killer app is going to be that will make 5G really, that will make us look back and say, oh, without 5G, this could not have been possible. So thank you so much to both of you for this absolutely wonderful webinar today. We are very privileged to have had the two of you with us today. And our audience, of course, thank you so much. As Pamela said, without all this enthusiasm, this webinar would not have been what it is. So thank you for being with us. Incidentally, we're going to have on the 9th of April a talk by Dr. Murali Narayan, where he's going to talk about the what is required to make autonomous vehicles work. So we look forward to having all of you with us. Please do go to our the IITACB YouTube channel. All of these talks are going to be up there. And thank you once again, everyone.